We are going to discuss about the application of image super resolution. So in the last video we already saw about the introduction to the image super resolution, how image super resolution we are going to work on, and what's the definition of image super resolution. For this video we are going to see about the application where we can use the image super resolution whenever we have developed some deep learning based image super resolution you want to use somewhere to upscale the image, which application you can just go for. The first we can just write here there about the display basically means that we can just improve the quality of any images or any videos by using this image super resolution model. So it basically we can just call display as a for the smartphone, for the tablets, and for the TVs. So we can just increase the quality of that specific display. The second, we can use the medical imaging. So what basically means the medical imaging? So we already know that in the basically on the medical field there is something we call as a MRI and CT scans. So that specific has the low quality of scan, or if you have the low quality of CT scans, you need something model. That model will able to capture the low quality pixel or whichever details we have in the scans, and on the basic of that it can increase the high quality pixel, or it can upscale that images by the factor of 4 or by the factor of 2. So whenever I'm just saying the upscale generally means that suppose you have the image of quality 200 cross 200. Okay, now we want to upscale that image by the factor of the 2. So you are going to get a new resolution of that image will be, we can just say as a 400 cross 400. But we are generally not only increasing the pixel, but we are increasing the pixel quality. It's not like you are just going to multiply the every pixel with a factor of 2. We are just multiplying, but plus about the deep learning is that we are just increasing the quality of every images, the quality of every pixel. And for that basically we can upscale by the factor of 2, by the factor of 4, or by the factor of 8, whichever the deep learning model you have just trained. So basically the in the medical we can just upscale by the factor of 2 or by the factor of 4. If we have any MRI or CT scan that is really a low quality image, now we want to increase the quality, we want to see more details about the inside the scans, so we can just easily go with the image super resolution models. The third thing, we can just go with the printing. So printing is really the most common we are using for the image super resolution. So we can just improve the quality of the images of the printing by using the image super resolution technique. So that basically allowing the printer, that is whichever we are just going to print it, that is generally giving us a high resolution images, and that will contain some more details on that. So basically the most use case we can just see about the in the second slide is basically photography. So photography, where we see that it is really the most useful case. And basically why? So we can just improve the quality of photographs, or whichever, suppose you are using some cameras, inside some cameras of the Samsung, or whether it is a Kodak or say Sony camera, we have one quality of the, if they are using the image super resolution quality, they will give an option. If you want to enhance your images by using the image super resolution technique, or that is enhance the image using AI. So that is basically they use the technique of the image super resolution using deep learning models. So that models generally not increase the quality of image, or it does not increase upscale the images, but also it captured the more details, and that image will be really look more realistic. It's not simply you are going to increase the upscale the images, and that images is generally look like something bad quality, or the something pixel has been distorted. So that is not the case in the image super resolution. We have to just think about more details, how we can just how gather the data set, and then after how we can just train. And training process is really the most important thing in the in the image super resolution models. And we will see this thing in more details. And the fourth is basically fifth, we can just say video. Also we can just improve the quality of any video, because video is generally has n number of images. We can just pass the every frame, or we can just n number of frame. We can just generally pass the frame, and each frame we can just apply a image super resolution technique. But that is not always the case for the videos. For video generally we use moving and moving capability, and there is so many technique in the video super resolution that does not simply we can use image super resolution on the videos. But yeah, we can just generally go with the videos and we can just use any image super resolution on that. And then after, if we have n number of frames, we on the every frame we can just apply a image super resolution. That is generally it will give you the better quality whichever we have the previous. And also the other application we can just use as a microscopy. We can just use the microscopy. That is really the most important factor. Suppose you are going to go something with the microscopic, and then after you want to just see the more details on the whichever we are just going to see, then we can just upscale that images by the factor of 8. That is really giving us more even details whichever we can't able to see. And the second also we can just see about the satellite imagery. So in the satellite also, whenever we know that it's give a blurry image, it's not a high quality image we are going to find on that. And also in the surveillance, so surveillance, basically you have some CCTV camera, and now what we do, we want to just increase the quality of that image. Suppose you have the CCTV camera, and then camera is able to focus or capture the videos whichever we have just placed whenever we have just placed. We can just perform really the basics application again, and say you have CCTV camera, you want to go with the face recognition, like it is going to detect on the camera. You're just placing one deep learning model that will able to just capture the images of the face, and it will just perform the face recognition for something. Like if that model will or that camera will able to recognize your face, then door is going to be open. So for that also we can use the image super resolution in between them, because what the CCTV camera is going to give you the images that might be a low quality of images, but make sure that face, each and every features of the face is going to visible in the darker side, or the in the, we can just say in somewhere in the we have something blurry image might it got. So for that we can use the image super resolution, because even it is going, if it is going to capture the lost pixel, and it can able from generate that lost pixel from the low quality of images to the high quality of images. So these are the application we can just use, and it is using everywhere. We can use the image super resolution where we need, in between two application you can just use the image super resolution. Where we need that resolution of that images, we can just place the application or that specific models, and we can just perform the image super resolution on that. So that's all for this specific video, and then after next video we are going to see about the working of image super resolution, the training of image super resolution, then GAN, SR GAN, and so on. Okay.